Hi there. For this video, we'll be discussing about the intercept form of a line. So, we first recall from the previous video, we learned that given 2 points in a line, we can obtain an equation which is given by y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times the quantity x minus x sub 1. This out here is called the 2-point form. Now in this video, we'll be discussing about a special case wherein the 2 points given are the x and the y intercepts. That is, we can move this one out here and this one out here. So we will be dealing with this case. Now, this case is called the intercept form, and we'll be deriving this using the 2-point form. So, first, we note here that the 2-point form is given by y minus y sub 1 equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times x minus x sub 1. So what we do first is we set our x's and y's out here. So in here we can set this to be x sub 1, this to be y sub 1, this to be x sub 2, and this to be y sub 2. Note that this is interchangeable since it does not matter which point we consider as the first point. Moreover, just to be clear, take note that this out here represents our x-intercept, and this out here represents our y-intercept. If you don't know what the intercepts are, I will put a link around this video explaining what these are. And now let's go on with the proof. So what we do here is we just plug in our x sub 1, y sub 1, x sub 2, and y sub 2 in the 2-point form. So we'll have here y minus y sub 1 is 0 equals y sub 2 is b minus y sub 1 0 all over x sub 2 is 0 minus x sub 1 is a times x minus x sub 1 is a. Simplifying this, we'll obtain y on the left side and negative b over a out here times x minus a. From here, we can multiply a both sides, and take note that we can do this since if a is equal to 0, then our initial equation would be invalid in the first place. since we'll have here 0 in the denominator, and we know that to be undefined. So by multiplying a, we'll obtain ay on the left and negative b times x minus a on the right. So basically, we cancelled out the a's here. Next, we distribute negative b to both terms inside to obtain ay equals negative bx plus ab. From here, we move negative bx to the left, or in other words, we add bx both sides to obtain bx plus ay equals ab. And lastly, we simply divide both sides of the equation by 1 over ab, or we multiply 1 over ab both sides, or in other words, we divide ab both sides to obtain, let's try to minimize the space out here. There. To obtain, first we have your x over a, since the b and b here would cancel. For the next one, since a and a out here would cancel, we'll obtain y over b, and lastly on the right we'll have 1. And this out here is our intercept form. Take note that the a out here represents the x-intercept, and the b out here represents the y-intercept. So this is the formula that we need to remember and memorize for our future calculations. So before we move into the examples, to explain the significance of this formula, take note that learning this formula is good since it makes our calculations much simpler and faster when we are given the intercepts, compared to using the 2-point form. This one is much faster since we are just plugging in 2 values. Now let's try to work on some examples. So in here, we are tasked to find the equation of line in slope-intercept form that intersects the x and y axis at -3, 0, and 0,5 respectively. Before we solve this, feel free to pause the video so you can try this one out on your own. Okay, let's start. So first, take note that our goal equation form is the slope-intercept form that is given by y equals mx plus b. Next, even though it is not explicitly stated, take note that since it was mentioned that the points that we have intersects the x and the y axis, we know that these points are the intercepts. More specifically, this one out here is the x-intercept, and this one out here is the y-intercept. Also, even if this is not stated, take note that since one of the coordinates is 0, then we know that these must really be intercepts. So, from our formula above, so recall that the intercepts form is given by x over a plus y over b equals 1, with this to be the x-intercept and this to be the y-intercept. So we use this in our calculations. So the equation using the intercepts form is given by x over this one, -3, plus y over this one, 5, equals 1. After this, since our goal is the slope-intercept form, we know that y must have a coefficient of 1. So to do that, we can multiply 5 both sides. And this would give us -5 over 3x plus y equals 5. Lastly, we know that y must be isolated on one side of the equation. So we move this to the right side to obtain y equals 5 over 3x plus 5. And this one out here matches the slope-intercept. Therefore, we conclude that this out here is the final answer. As you can observe, using the intercept form is much faster. Imagine if we apply the 2-point form out here. Then that would take us a lot of time in arriving with this answer. There. Now let's go on to our second and final example. So given this graph, we find the equation of the line in, this time, the standard form. So feel free to pause the video and try this one first on your own before proceeding in this one. Okay, let's start. Based on the graph, even though the points or there are no points present, we can observe that the line intersects the x and the y axis. So this one is the x axis, this one is the y axis at these points. So we know that this out here is the y-intercept and this out here is the x-intercept. So to write that one down, we note that 4 is our x-intercept, and -1 is our y-intercept. So applying this to our formula, let's move this first. So take note again that the formula is given by x over a plus y over b equals 1, wherein a is the x-intercept and b is the y-intercept. So applying this, we'll have here x over 4 plus y over -1 equals 1. Now, take note that the standard form is given by ax plus by equals c, wherein a, b, and c are integers, with a being positive. So to arrive at this form, we need to eliminate this denominator of 4 on x. To do that, what we can do is we can multiply 4 both sides. So that will give us x minus 4y equals 4. And actually, this out here is already our final answer. Indeed, this one is already in standard form since the coefficients of x and y are integers, and the constant out here is also an integer. Moreover, the coefficient of x is positive. Therefore, this really is indeed the answer. And that is how we use the intercept form. There. So to end this, here is an exercise that you can work on. So in here, we are tasked to write the standard form equation of the line shown below. So the process here is similar to our second example, but this time we are given 1 point here, 1 point out here, and no points anymore out here. But as you can see, we are given that this line intersects at this point. So clearly, we can apply the intercept form. So this is something that you can try, and feel free to comment down below if you have an answer or a solution to this one. So that's it. I hope you enjoyed this video. Feel free to comment down below any suggestions and recommendations that you have for future videos in this channel. So that's it, and that is all for this video.